Okay. So thank you everyone for joining us in the first open mic. Just a few technicalities. We want everybody to participate as much as they can. So if anybody wants to talk, just raise your hand and with the reaction button, just choose raise your hand and we'll open for you the microphone. You are welcome to submit questions on the chat, and we'll be happy to address them during this event. And last thing I'd like to mention, we also have the Discord. So if anybody's cut off, unable to stay in the Zoom, you're welcome to join us in the Discord and submit questions over there, and we will address them next time. Anything else? Let's start. Let's see a few of the questions that we've had. So first question, how would you decide max number of mem tables for balanced performance? Mike, Haley, anyone wants to?
I'll try to answer. Number of mem tables. We'll start with there are three parameters that impact the performance. The first one is the size of the mem table. The bigger the mem table, the harder the insert, because of skip list is a B tree basically, and if you've got millions of elements inside it, then it's going to cost you in performance. This has been eased with our new implementations of the mem table that is coming soon, but still larger mem table costs you performance. Now, on the other hand, if you have a small mem tables, you're going to pay in write amplifications. So doing this balance is something that needs to be done. What we would recommend is never to use the default of Rocksdb of 2, because one is written into, one is being flashed, and if you are not successful in flashing while you are writing into the second one, and the second one is full, you will get into store. So we don't recommend using the default of Rocksdb of 2. We recommend to use it something like 3 or 4. I hope that makes sense.
Yes, just I'd like to add that it's very important to take the memory that you have into consideration, especially if you have a large number of column families, and each one will have a set of mem tables. So if you have lots of memory, you can increase that number, but just make sure it won't exceed your limits.
Yes.
What would be the benefit of having more mem tables, and what would be the downside of having less mem tables?
Okay, so 2 is the boss. I mean, 2 is basically one is written into, one is in flash, and if you are writing too fast and the flash cannot keep up, you will end up in store. 2 or 3, if you have a single column families, I would recommend using 4, and basically this is, and then there will be a slowdown, gradual slowdown also, but using 2 is not allowing the system to slow down before it's stalled, and it's this is the main thing. The second thing is the size. It depends on the number of elements that you're going to put inside the mem tables. But we have tested it, and when the number of elements exceeds 1 million, you'll see performance degradation on it. So it's better not to use a too large mem table and to use multiple mem tables.
Cool. Thank you, Mike and Haley.
Anyone would have something to add or ask further question on the subject? If you can raise your hand, we'll unmute you, and happy to have it as a discussion. Right?
Okay.
Yeah.
We'll continue to the next question. What are the key considerations when configuring block cache? Anybody from the team wants to take it?
Mike, go ahead.
Well, again, one of the main considerations is the RAM size, it's available RAM size. And if you have lots of RAM and you really need that cache for different purposes, maybe for the block cache, or if you cache index and filter blocks for your index blocks, the more cache you have, the better the hit ratio is going to be. But again, it really depends on your workload. And also, if you have lots of RAM, consider using instead of using it for block cache, use it for pinning of indexes and filters. It will improve your general performance.
So that's very interesting. Why would pinning the indexes is more important than general read cache or block cache?
Because well, if your indexes or filters fall out of memory and because you don't have enough, you'll have a huge hit on performance. Each time you need to read an index, it can be very large read from the drive, from the disk, the same as filter. So it's first of all, it's important to have indexes and filters in memory, and then the available memory can be used for block cache. Again, if you don't really need block cache, for example, if you're doing mostly writes and then random reads, and you won't have a really good hit ratio, in that case, you may not need a large block cache. It's really, it all depends on the workload, on your actual workload, on your resident set size.
Allow me to add to this point because it's extremely important. When index fall out of cache, usually oh, sorry.
Bless
Usually
you, the one who
bless you.
comes.
Yes.
Sneeze.
The indexes are usually compressed, so you need to decompress it. They are usually large blocks and they needed to be read from disk, and this is taking, like Mike said, a long time. And in Rocksdb implementations in the default, the ratios of there is one index per file, but there is 60,000 blocks. So indexes are extremely more important, and the LRU mechanism, even with the high priority, does not provide a good answer for that. Things are falling out of cache, like indexes and filters falling out of cache, and this is something we are working on. And we'll think about it in one of the next versions, how to resolve this without risking out of memory.
It's also important to consider some other things. For example, non-sharp bits can improve performance. If you're using the regular LRU cache, if you increase the non-sharp bits, it can improve the performance of multi-threaded applications, but sometimes it can cause unwanted effects. For example, indexes will not fit into your shard, so it's also important to see all the other considerations.
Cool. Anybody wants to add anything, add questions? Just raise your hand. Okay, we'll move to the next question. What is your first step for troubleshooting performance issue? Can you walk us through logs?
Logs. Oh, we don't have any logs.
Yeah, well, walking
No.
through logs might be a big request for this session, but how would you go about starting investigating performance issues?
Well, first I would check the sizes of all the column families, check the options that are used, check all the warnings and errors, of course, if you have stalls, if you have any slowdowns in the logs. I would also check if statistics are enabled or not, and if possible, enable the statistics, because it will allow us to see the actual performance for each, for reads, for writes, for seeks, and also not just performance, Rocksdb performance, but also the actual reads from SSD, from the disks. See the histogram of the reads, and decide whether, I mean, if we don't know the problem, we start with the logs. And but if we know what the problem initially is, for example, we get very slow reads, we can see if the problem comes from the drives from SSD reads, or it comes from having from bad hit ratio. All that can be seen in the statistics.
And one
And
thing-
also right application, for example, which is a very common problem. We can see even without statistics, we can see that we have very high right application.
One thing that we are working on, and this is a work in progress, is a log parser that we are trying to create databases out of the log and then enable you to plot the informations that we are getting out, which will make it visible and not just scanning this file and trying to figure out whatever, I mean, based on the comments, etc. So we are working on a log process, and we will share it with the community once it will be ready.
Cool. Guys, anybody wants to ask anything, add questions? I'm just reminding you, if you want to submit any questions, you can do it in the chat. Just raise your hand.
And also, anyone from the room, do you have your own set of go-to parameters or go-to logs or parts of the log where you have any kind of performance issue, things to investigate first? It would be great if hear some more of you guys if you have any good ideas as well. All right. Next.
Yeah, no worries. Okay, next question. Would you recommend pinging the index or the data?
Well, actually, we touched the subject before. It's very important for the indexes and the filters, not to fall out of memory. So pinging is definitely recommended. But if you have a choice, just don't put it in the cache and pin everything in memory. If you don't have choice, then we would recommend pinning top level index and at least pinning top level and see what else can be done to avoid evicting indexes and filters. About the data, I'm not sure I understand.
Yeah, well, it's dependent on the workload. I mean, there are many workloads that are used recently written data, so you want to pin memory buffers into memory, and this is an option that exists in Rocksdb. So you keep your recent data in memory. Those are existing options, but we cannot answer it without fully investigate our system and trying to understand them. And then, so eventually we will have auto tuning, but it's eventually something we are working.
Okay, I see we have a question. Let's see. Regarding preference debugging, checking Bloom filter hits and the log column family statistics is useful to see if they are doing anything.
So Joshua is adding for the performance question, checking the blue filter to make sure if you're just not wasting memory if they're not giving you any value. Thank you very much for that, Joshua. And we have an incoming question.
Brent.
Do you have any best practices or recommendation on dealing with backups or fault tolerance? We're designing a system with hundreds of nodes, each with its own Rocksdb. How do you recommend doing backups and restore? Example, I lose one node. Okay, I got the example. Do we periodically back up checkpoints, snapshots, backing up SSD files directly, etc.? It's a good question. Thank you, Brent.
So checkpoints are very expensive. They are taking a hard link and in order to take the hard link, they need to do a flash of the entire column families of all the column families of this database. So checkpoints are extremely expensive. What I would recommend, and this is something that can be done, is to we will work on it. I mean, this is something that we will work on and improve the checkpoints. We have ideas and we will be happy to share them with the community when it will come visible.
Okay, so checkpoints are expensive, but with the existing functionality in place, how would you recommend backing up system hundreds of nodes of Rocksdb?
No other ways except checkpoint. This is today. I mean, I don't know of any other way except of for a. I mean, secondary database can be used for backup. This is something that was, and you can use it a secondary database so that will get all the writes, and eventually you can do a snapshot or checkpoint on the secondary database, so that your workload will not be interrupted. But this is.
And how will you make sure the secondary database is synced with the primary one?
This is something that Rocksdb is making sure.
Yes, there is a catch-up in Dorfman. There is a way.
Yeah.
You can open a secondary database and just catch up with the first one. Again, I don't think it's an easy question to answer. We really have to know the specific requirements and the available infrastructure. I think that can be taken offline for the specific use case, because it's too generic.
So Brent, if you want to elaborate more here, then please do. And if not, please shoot us a question on the Discord. We'll be happy to dig deeper into your use case and give you the best recommendation we can. Anyone wants to add anything regarding backup? All right.
If we've got the audience, how important are checkpoints and zero impact checkpoint? Because this is something that we have developed in places before, and I'm thinking of ways to do it. Do you think it's important? And you know, I mean, it's hard to ask in the Zoom, but
We will do a survey on the Discord. Thank you, Philip. We'll do a survey on the Discord as to your general feeling around checkpoints. Would you like to improve it? Would you like to do it better, and so on? Thank you. Dan, please.
Yeah. Next question. Assuming I have a very large keys, what would you recommend I change from the default configurations and why?
You have large keys, you may end up with very large index if you don't change the default configuration, because if you set leave the default block size of 4Ks, and for example your key is a few Ks, you'll end up with 1 key per block. So the index will be huge. It won't fit in. It may not fit into memory. So the most important is to choose the correct block size for your keys. Check that in order to optimize the index size. You can easily see what the index size you are getting in the logs. It's actually something that I forgot to mention. It's very important to see what you get on each flush. What is the data size, the compression results, the index size, the filter size, and optimize so it stays in memory. again, so you don't end up with very large index. So what else?
Question.
I will start with from the beginning. You need to go back to your drawbacks and think about your large indexes, because large keys are maybe an easy way out, but this is it will cause you performance penalty and whenever you're doing compare of keys or anything like that. So think again before you're using keys of 1K, which is what we have seen. But if you don't have any way around it, then you need to consider how big is your block, just like Mike said, and make sure that your indexes fit into cache and not and you won't end up with an index size that is equal to the database size.
So you're saying basically, if I have big keys, first I need to reconsider not having big keys. But if I do have those big keys, play with the block size to make sure that the index doesn't effectively hold all keys. Was that the point?
Yes.
Okay, thank you. We have another question.
Wait, Noam wants to say
sorry,
something.
please, no.
Let's give,
Yes, I would just like to add that it might be also beneficial to turn on the bloom filter if you have large keys, because the fraction that the filter will take in memory will be, compared to the database, will be very small in those in this case, and you might really benefit from not doing point queries where you will have to compare large keys to one another. So that's maybe another thing that is worth doing.
Thanks, Noam.
Thanks. I see we have a question from Will. Would you guys recommend enabling Roclsdb and in an attempt to cut down on write amplification? What are the downsides of enabling Roclsdb? Is there a certain value size at which Roclsdb should be used versus keeping the value in the SST file?
So the downside of using Roclsdb is the fact that you need to do 2 reads instead of 1 to get the object. If you are using the data inside the LSM tree, then 1 read is enough and you get the object. While if it is in the Roclsdb, you need first to read the pointer to the Roclsdb and then after that read the data. Now, with the current SSD performance, probably you should go to Roclsdb if the size is over 4K or something like that, because then the time that it takes you to read two elements is almost the same as reading 1 large block from the SSD. Now, about the write amplification, yes, of course. I mean, the Roclsdb are a lot better than LSM tree because the data does not need to be sorted. The other downside that I know is that the space amplification of blobs is usually higher, and the garbage collection of the blob is not so good, and this is something that we will eventually look at, but if there is a requirement. But currently it is working extremely well, and there is if the data size is over 4K, probably you should go into Roclsdb implementation instead of using the normal
Steve, I see you want to say something. Let me unmute you.
Yeah, sure. So I think that was a good answer. And just to add to that, if you really care about scan performance, in that case, Roclsdb is not a particularly good idea, because in Roclsdb, if you're trying to scan a given key range of entries, the actual values will be in random locations in the log. So each entry you're actually trying to access will lead to some random IO in the log. So if you really care about scan performance, it's actually better for the values to be embedded inside the LS entry, then you can scan them very quickly. But of course, as the values become bigger, this hits you less because the cost of the random IO in the log becomes more amortized. So yeah, so generally the bigger the values are, even if you have scans, it's a good idea to use blobdb, but especially for small keys and if you care a lot about scan performance, then blobdb is probably not the best idea. So yeah, it's workload dependent.
Thank you, Dave.
Anybody else has anything to add? One second, I see. Okay.
Thank you, Will. Yeah.
Okay. When should I use universal compaction and when should I use level?
Level compaction, it's the most common compaction. It is basically working and it is working extremely well. I mean, if you don't have a very heavy write load and if you are, and okay, and the compaction is basically level to level. So this is, and every level that you add is increasing your compaction write amplifications and by X. It is the most commonly used, and we recommend almost everybody to use it. In Universal, what happened is that everything seems to work fine until you hit the threshold or point where the database needs to go into a full database compaction, and then it is stalling for a long time. We have seen stalls for minutes, which is on databases of 20 to 30 gigabytes. So Universal is suited if you have a burst of write, and then after that, you have an idle time so that the database can recover from this burst and make sure everything is clean before it. Otherwise, if you are writing constantly into the database, you'll have to use the level compaction.
Mike, you have anything to add?
Well, we can add about our compaction.
No, I
No.
think it's less relevant. No. Guys, anybody else wants to add anything?
Neil, would you like to give your view on level versus universal?
Okay.
Okay.
Yeah.
And you?
Here you go.
So yeah, so I'm not completely up to date on the latest version, but and I think what Chilik said was all correct. And so I mean, maybe I can just add a few more things. As far as I understand, at least in the previous version of universal compaction as well, once you're doing that large compaction at the largest level of the LS entry, that can also require you to have at least double the amount of storage capacity as the amount of data, because you're writing you're basically copying all the data, and you can only delete the original data once you finish the compaction. So it's I'm not sure if that's still the case, but at least in the previous version of Rocksdb, yeah, you needed a lot more physical space in your data to be able to use universal compaction. Now, the main advantage of universal compaction, I guess, is write amplification. So less compaction, less greedily. So if you really care about writes, you can opt for it. But another disadvantage is with universal compaction, because it's using I believe it's using a smaller size ratio by default. So you'll also have more levels in the tree, and that might lead to worse scan performance because you'll have to traverse more levels. So that's my take. Yeah.
Thanks, Dave.
Cool. Thank you. Guys, anybody else has anything to add? Questions? Perfect. Moving on. Is there a compaction trigger to remove tombstones?
I believe the default compaction priority actually takes in account the tombstones when there are too many of them. The file is considered for compaction, but if it actually can be modified to, we can add our own compaction on delete table option just and decide. It's not very hard. You can decide for a sliding window if it has too many deletions. For example, you have in 1000 operations, you have 100 deletions. You can decide to prioritize and mark the file for compaction. It's easy to do. If you need an example how to do it, just write us and we'll set up an example. You can add your own in table options your own compact and delete factor. And again, if it's important. The question was, should we do it, or if the question is, should we do it? If well, having too many tombstones both enlarges your database and also can degrade seek performance because you have to skip on too many tombstones. So, if you see a problem with that, again, we can see with the connection with the statistics, you can see that you have too many next on each seek. And extend without finding anything, then if you see that in the statistics, you definitely should fix that problem.
So why shouldn't I?
Well, if everything works fine for you, you don't see any problems with six, you can keep the default because the default also takes into account. Just it needs a lot of tombstones to actually to mark the file to prioritize the file for compaction. We have priority, compaction priority, and the default.
The Rocksdb and you build them have optimized seek so that they will skip over tombstones and range deletes, etc. But again, it is better not to have the range delete. But if you do have it, then the compaction triggers, like Mike said, will kick on by default unless you will write your own compactions, deletions, delete on compaction, delete factory, and you can do it yourself. So the answer is, well, if you need something, then we will be happy to assist you.
But before handing to Niv, I'm just going to say that the end of every question is if you need something, we'll be happy to assist you, and we actually mean it. So this is, of course, not going very deep into any subject. If you want to elaborate, please shoot us a question on Discord, and we'll happily go as deep as you would like. Niv, please.
Yeah, so just to add to that, there's another parameter that I really like in Rocksdb. It's called something dynamic capacity adaptation. And what it's doing is it's shrinking the capacities of smaller levels in the tree based on the actual data size at the largest level. So if you're using that parameter, it kind of guarantees to you that the total amount of space amplification that you're going to have in your system is, about 10%, which matches the size ratio. So another approach to, so one approach to curb space amplification is to proactively remove tombstones, and you can do that. But another approach is to enable that parameter, and that's going to guarantee you at most a space amplification of basically the inverse of the size ratio of the LS entry. So yeah.
Thanks, Niv.
Perfect. Does Speedb do compaction? Did you measure the compaction overhead in Rocksdb? If so, how much will the overall performance decrease? And where is the bottleneck, computation, or storage stack?
It really depends on the performance of your drives. If you have a really high write application factor, for example, for each byte you have to write 20 bytes for the drives. So, and you do a lot of writing, it can really affect your performance. Just for example, if you're writing 100 megabytes and your write application is 10, you'll have to write 1 gigabytes per second of disks for compaction. If your storage, underlying storage can provide it, it's fine, and then other things will be the bottleneck. But if it can't, for example, you have a cloud storage, then you'll be very limited on your write performance. You'll also experience stalls and slowdowns. So the most important consideration is your storage performance. Now, what was the exact question about the CPU time?
You measure the compaction overhead.
So we measure it all the time. Compaction takes a lot of both CPU time with compression and reading from disk and write. It takes a lot of CPU time, a lot of bandwidth, both for reads and for writes. But again, the exact bottleneck depends on your hardware. If you have many CPUs, then CPUs really isn't a bottleneck. If you have large NVMe drives, it isn't a bottleneck. If you don't have any of those, then any can be a bottleneck.
So usually compaction is going into one CPU. So this is especially if you are using a fast rise and compression, the bottleneck will be the CPU. You can parallelize the compactions, or you can use sub-compactions if needed in order to resolve the CPU bottleneck, single CPU bottleneck. And then you will end up at the drive. As Mike said, I mean, the compaction is one of the major things that running on the system if you have a heavy write load, and we measure it all the time.
Cool. Thank you, Pity. Anybody else has any questions, anything to add? Yeah, I see. Well, here we go.
I'd just like to add about the deletion collector factory, that a downside using it can be additional overhead and limitation of the L0, L1 compaction bottleneck. So if you trigger compaction more often because of each file that goes through, then you're increasing that overhead of compacting each new level 0, and with the entire L1 if it overlaps. So that could be a downside.
Okay, thank you. I see that we have a question from the chat. Second.
So the question from the chat is, the Speedy marketing material talks about sharding and how we don't need to worry about this ourselves. What is going under the hood here? Do you use rocks prefix to determine which shard to use transparently? Thank you, Matthew, for the question. So the SpeedB marketing that you're referring to is for our enterprise version, where we employ a different type of compaction and some other enterprise features that are mainly intended for scale. So when we are saying that you don't need to shard the data, that is because we can grow quite dramatically in the single data set without the need to shard. This is for customers at scale, and this is in our enterprise version. You want to add?
To expand a bit, I mean, something that people cannot think about when they do sharding is the seek performance of sharding. The seek performance when you're doing sharding is basically you need to go to each shard, I mean, and do the seek over there. And then basically you are tripling or quadrupling the effort to do seek or scan of the database. And this is a major problem in some customers. And what we offer is the compactions that can you can work with terabytes of data and have a reasonable write amplification, but this is only in the enterprise because we didn't see a requirement from it from the.
So let me set the stage here a bit. So SpeedDB, we have our open source product. We have the open source repo, which you of course more than welcome to log in the GitHub, have a look, contribute, comment there. This is basically Rocksdb with some additional features that we keep on adding more and more features over time. We'll keep on porting more features from our enterprise version to the open source version, and we keep on developing features in the open source version. And for that end, we do appreciate pull requests, we appreciate contributions, and we will release some more and more pollings to see what the community actually wants us to work more on. Next to that, we have our enterprise version, which is built on top of the SpeedDB open source with some added features, mainly the compaction, but not only, which is our different approach to how to do compaction, still LSM, still based on SpeedDB, still behaves exactly the same, only a different compaction methodology that will allow you, as Chilik just said, to scale quite dramatically into a single data set, and we are talking about terabytes, without an uplift in your write amplification factor. The differentiation between the enterprise version and the open source version is at scale. So the open source version will have all the capabilities of the enterprise version up until capacity point, and then we move to the enterprise version. I'm happy to take any other questions if there are around this issue, or if anyone else wants to comment.
Mark, was there anything you wanted to say?
I'm good on this issue right now, but I think we need to, yeah, I think there's a lot more we can do going forward. So looking forward to the contributions. And we're moving contributions from the existing Rocksdb community over into the SpeedDB as well. So if there's any that should be any ones that are being flagged by specific users, please raise them and we'll investigate those first.
Absolutely.
Great, thank you, Mark.
Okay, guys, anybody else has any additional questions, anything they want to add? Okay, seems like we ran out of questions for now.
So folks, thank you very much for joining us on this first, but definitely not last open mic night. We are happy to have your questions beforehand or during the conversation. We enjoyed ourselves very much. We hope that you guys did too. We'll post on the next event. Please come prepared with questions. And of course, if you want to go deeper on any specific issue, or if you have any further questions, please join our Discord and ask it there. This is where we live. And of course, go to the GitHub, download, play with it, and tell us what you think. Thank you very much, everyone.
Thank you, guys.
Thank you.
Thank you.
Bye-bye.